Good afternoon. Welcome to Central Philippine University, and today we will discuss programming in MATLAB. Okay, once again, welcome to our topic on MATLAB. And today, we will create more programs, that solves problems under our subject, Advanced Engineering Mathematics. Now, for our topic for today, we will be discussing how to get input from the keyboard. Okay. That will be our first discussion. So you go to new and live script. Now, in our live script, we will type, we will create a program. Okay, create a program that gets a user input. Okay. So let's start by finding by getting a user value, and we will store that to x. Let's say enter a number. Okay. Enter a number. That's how you write your input, guys. The command here, input, means you are going to read inputs from the keyboard. Okay, the input will be stored in the variable x. So if you entered a number and then we stored it to variable x, and then what if, we will compare x. Now, if, let's say, if x is greater than, let's say, greater than 0, then we are going to display, take note, we have discussed this before, the display. The number, okay, the number is greater than 0. Delimiter, then okay, that's it. If you input a number, okay, the program will ask you to enter a number. Now, if the number you have entered is greater than 0, meaning to say, this will be displayed. Okay, it will display the number is greater than 0. Okay, this will be our program. So let's have an end. Let's end this program, and we will run the program here. So clicking the run all. Okay. Now in your command window, you will be prompted now to input or to enter a number. Let's say I will enter 5. Press enter, and in the output screen, okay, this is the output screen. What is displayed here? The number is greater than 0. So the number is greater than 0 is displayed here. Okay. What if now I will input, okay, let's run again, and I will input a number less than 0. What is displayed here? Nothing. Okay. Nothing is displayed because from going back to our program, our program states that if you only enter a number greater than 0, then you will be prompted the number is greater than 0. Otherwise, none. Okay. So we will create an else statement here. Else, meaning if a number is not 0, if a number is not greater than 0, okay, it will display, okay, let's say the number is less than 0. Okay, it will be display. It will display the number is less than 0 if you input a number which is less than 0. Let's try. Run the program. Let's input 10. What will be displayed here? Yes, of course. It will display, once you press 10, the number is greater than 0 will be displayed here because, take note, 10 is greater than 0. Now run the program again, and let's have -5. What should be the output here? Okay, the output, the number is less than 0, which is correct. Okay, the number is less than 0. Let's try again. What if we enter the number 0? What will be displayed? It will display the number is less than 0, which is wrong. Okay, so we will need to add another else statement here. Okay, in this case, now else, now we will label this as else if, okay, else if the number is less than 0, okay, it will display the number is less than 0. Else, okay, meaning to say if the number is greater than 0. Now if the number is not less than 0, so meaning it is the other number, it is else. Else, it will display the number is 0. So that's how you write program using the else if statement. Else the number is 0. Let's try. Okay, run again. I will input 10. Okay, it will display number is greater than 0, which is obviously greater than 0. Okay, let's try again. So I have here -2. And here -2 is less than 0, which is correct. Okay, run again. Now, this time we will input 0. The number is 0, which is correct. So this is how you write your basic programming using if-else statement. Okay, like for example, okay, let's add one more here. What if I entered another number, another character, not a number? What will happen? Let's say if I entered a, since in your program you are required to enter a number, so this is wrong. So you have your input is not correct. So you will go back to input the correct number here. Let's say 5. So it will display, oh, the number is greater than 0 because you have entered 5. So this is how you do programming using else if, else and statement. Okay. Now, if you have more than one what you call argument, so you can add another else if statement here. Like for example, if x is greater, okay, let's create another problem here. Let's create another problem here. Let's clear this up. Okay, here is the problem. Okay, the problem states that, okay, create a program that will display the following letter grade. Okay. Okay, will display the following, okay, letter grade. Okay, create a program that will display the following letter grade based on the row scores. Okay. Here are the row scores. Example, your grade, this is your grade, row scores. Again, okay, your grade will be A if your row scores is between 90, it's greater than 90. Grade score, let's say, score is greater than 90. Of course, up to 100. Okay, another one, your grade will be B if your if your score is between, let's say 80, equal, less than or equal to score up to less than 90. Okay, if your score is greater than 80 but less than 90, your grade will be letter B. Letter C. If your score is greater than or equal to 70, greater than or equal to 70, but less than 80. Let's have another one. If your score, letter D, is less than 70. Score is less than 70. So meaning your grade is D. Okay? So that's it. Let's create a program that will solve this problem. So let's make this a little bit smaller so we can create a program here. Let's start our program by by using this variable grade or score. I mean score. Let's label this as score. Score input. Let's say enter your row score. Okay, that's it. Now enter your row score. Don't forget to add a delimiter. So what are we going to do with the row scores? We are going to create an if statement that will solve your problem here. So let's start with the if statement. If score, let's say, if score is greater than 90, okay, if score is greater than 90, then what are we going to do? We will display, okay, we will display the grade, your grade, let's say, your grade is A. That's it. Your grade is A. Else if, okay, else if your score is between, take note, your score is between what? A. So you can write this one like your score is less than 90 and end. Meaning to say, when you say end, you have to satisfy now that your score should be less than 90 and okay, your score is greater than or equal to score is greater than or equal to 80. That's it. Then we are going to display your grade is B. Okay. Another else if, okay, another else if your score, okay, is less than 80, okay, less than 80, but and then your score is, let's say, greater than or equal to 70, greater than or equal to 70, then we are going to display your grade is C. Okay, and your last statement is else. Else, meaning to say else if your score is not is below. Let's say we can label this as else if. So else if your score is less than 70. Okay, sorry for that. 70. Display, okay, your grade is D. What if now you have entered a score not in, okay, you have entered a different score. Let's say you can have else display you have an valid grade. All right. That's right. Let's end the code. And for the first item, so let's label this. If your score is greater than or equal to 90, let's say greater than or equal to 90, or if your score is greater than or equal to 90, meaning to say, if your score is greater than or equal to 90, meaning if your score is greater than or equal to 90 and let's say and your score, okay, is less than or equal to 100. Take note, the maximum score here is 100, so we need to input this one. Otherwise, if you entered 105 or score greater than 100, you will have a score of A only. Otherwise, no, you have an invalid grade. Let's try to run this code. Run this code, and you will be asked, no, to enter the row score. Let's try. I will enter 96 as my row score, and what will be the output? Okay, your grade is A. And here, no, if you have entered a score, okay, of 96, you will be your grade is A. Okay. Let's have another one. What if your score is 100? Still, your grade is A because 100, no, is A, right? So let's have a score greater than 100. Let's say 1000, 103. What is displayed here? You have an invalid grade because 103 is not found in your table. So it will display you have an invalid grade. Okay, now let's run again. Let's try if your score is between 80 and 90. Let's say 85. 85, your score is B, which is correct. Okay. In this case, now if your score is 85, now your grade is B. Let's have another one. Okay, let's say 75. Your grade is C for 75, and if your score is below, let's say 50, your grade is B. So that's how you use your if-else statement. Okay. Later on, we will be using if-else statement to solve problems in advanced engineering mathematics. All right. Now, this time, no, I will be using another method that can solve the same problem, but we will be using another method. Okay. So this method is what we call your. I will erase this part first. Okay. And we will create another problem here. We will be using the switch case method. This is the switch case statement. This is the case switch statement, that we will be using to solve the problem. Let's have one problem here. So for a case switch statement, let's have X as our variable. Let's say input. Take note, the command input is used not to prompt user to input from the keyboard. Okay. Okay, let's try. Let's say input. Let's say enter a number. Enter a number. And close that with a delimiter. All right, now enter a number. So what are we going to do next? After we enter a number, we have entered a number, we go to switch. This is how you spell a switch X. So then we will have case if the number is 1. Okay, display. Okay, we will display Okay. Hello there. What shall we say? You have entered 1. Okay. You have entered entered a number. All right. So let's say case 2, or let's say case 0. Okay, I will copy this one. Control C. Okay, Control V. Okay. Okay, we are going to, if case 0, you have entered a number 0. All right. Now case -1, let's say case -1, then display. Okay. You have entered a number negative 1. Okay. This is how you use the case. So n. Let's try. Run the program. You will be prompted to enter a number. So you have to enter only the numbers in your case. So in this case now, let's try case 1. Enter number 1, and it will be displayed case 1, meaning x equals 1. You have entered a number 1. Let's try another one. Case 0. Let's say case 0, enter. You have entered a number 0. Okay, case -1. Let's say, okay, case -1. Okay, enter. Okay, what happened here? You have entered a number -1. Okay, it is not displayed here. Let's try to edit this one. Negative. Run again. Let's try now. Enter -1. Okay, -1 is okay. Okay, okay. That's it. You have entered a number -1. This is -1. You have entered a number -1. Let's try again. -1. Oh, I'm sorry. -1. I'm entering here -1. Okay, you have entered a number -1. What if I will enter a number 2? Since 2 is not in the case, no, it will not display. So let's have here the number. Okay, we will display here. Okay, otherwise we will put another. Otherwise, if the number, if your x is not found in your case, you have to put otherwise. So you can have display. Okay, what the heck are you doing? All right, no? This time now I will be displaying what the heck are you doing. Now, if you entered a number which is not in your case, let's try. Let's enter 5. What the heck are you doing? Okay, that's it. That's how you use the switch case method. Any question? No more question. Then we will proceed with our topic under your Laplace transform. This time, I will read the values of the function of t, and we will take the Laplace transform of that function. Let's try. Here, now we are going to solve Laplace transform of any function. Okay, we will solve Laplace transform of any function. So I will have here f equals to my function. This time I will get function from the keyboard, enter the function in the variable t. Let's say in variable in variable t. Okay. Okay. So we are going to input a function in the variable t. Any question? All right. Take note. So we are going to change this function into we will change the text that you have entered. Take note, by default, now the text you have entered will be treated as a string. So we will convert this string value to function. So by putting eval, and then your expression. So eval changes your entered text to a function. Okay, now you have your function equals to f. Then before that, now we will have our function here to be our variable. We will define our variable here. This time we will be using t and s, of course, because we are going to take the Laplace transform. So s and t will be your variable here. So then what are we going to do with your function f? Of course, we are going to take the Laplace transform of that. So you can have here display the Laplace transform. The Laplace transform of f is, that's how you write your code. The Laplace transform of f is, this is the syntax to solve for the Laplace transform of your function. In this case, we are going to take the Laplace transform of f. Okay, now I will move it somewhere here. Can you see the code? I will make it more smaller so that you will see the output here. Okay. Okay, now let's erase this semicolon so that it will display our function. Okay. Run the code. You will be asked, to enter a function. Enter the function in variable t. Let's have it sine 2 times t. So entering sine 2 times t, press enter. Evaluate. Okay. It's not working. Okay, let's put this code before the function. So let's have it as f. Okay. Okay, again, we will run again. Okay, number. Okay. Run again the function. Okay. Okay, that's it. We will enter a function. Let's label that as t. My function is t. Press enter. What happened to my function? Eval input. Enter the function in t. Okay, display the Laplace transform seems. Let's try again. T. Okay, that's it. Your function is equal to t, and the Laplace transform of f is 1 over s squared. Okay, we will put a clear command window here before my sims so that it will clear my command window. This time I will input sine of 2 times t. Let's have sine of 2 times t. Press enter. And your final answer, the function of f is equals to sine 2t, and the Laplace transform of f is 2 all over s squared plus 4. That's how you take the Laplace transform of a function. So this is a really good tool in solving Laplace transform. Let's run again the code. This time, now we are going to find what is the Laplace transform of sine hyperbolic of, let's say, minus 2 times t. Minus 2 times t. Press enter. And okay, the hyperbolic function of minus 2 sine t is minus 2. S squared minus 4. So that will be your answer for sine hyperbolic minus 2t. So take note, sine hyperbolic minus 2t is the same as negative sine hyperbolic of 2t. What about the first shifting theorem? Let's try a first shifting theorem. Okay, I have here t multiplied by e raised to t. My first shifting theorem. Okay. Again, let's try 0. Again, run the program. Okay. E, I mean, take note, we have entered a wrong syntax for exponential function. So this is e at t times exponential of t. So that's how you represent e raised to t. So enter. Okay. Where's the answer? Ebal. Okay. Again, let's have this function. Oh, okay, that's it. Okay. Function of t times e raised to t is equal to 1 over s minus 1 squared. So it's delayed. Let's have another one. So I have here sine of 4t, let's say cosine. Cosine of 2 times t multiplied by the exponential of minus 3 times t. Press enter. And the Laplace transform of cosine 2t times e raised to minus 3t is s plus t all over s plus the quantity squared plus 4. So that's how you compute your Laplace transformation using MATLAB. But what if, now we will take the inverse Laplace transform. Okay, let's have this problem as the inverse Laplace transform. This time we will solve the inverse Laplace transform of any function. So this time we are going to enter the variable in S because we are looking for the inverse Laplace transform. Okay. Okay. Now for the inverse Laplace transform, the syntax is I Laplace, meaning this is inverse Laplace of your F. So I will make this F capital or uppercase F, and then run the code. Okay, enter. What is the inverse Laplace transform of 1 over, okay, let's say s to the 5th power? Press enter and you will be prompted as t raised to 4 over 4 factorial, which is t to the 4th over 24. So any question with the Laplace transform? Okay. How about the inverse Laplace transform? All right, so let's grab another one. Let's run again the code, and we will input a more complicated Laplace transform. Let's say s plus 3 all over, let's say s squared plus 2s plus 5. Okay, okay, plus 5. Take note of the multiplication. Multiplication. Okay, s squared plus 2s plus 5. Enter the function, and charan, that will be your Laplace transform, the inverse Laplace transform. So it will make your life in engineering easy, especially if you know how to use MATLAB. So that is the Laplace transform. Any questions about Laplace transformation? Okay, so that's it for the Laplace transform. Now we go to the Maclaurin series. So if you can still recall your Maclaurin series, okay, this is your Maclaurin series. Okay. If you can still recall your Maclaurin series, of Maclaurin series of x raised to n, okay, or Maclaurin series of sine, cosine. Okay, that's it now for your Maclaurin series. Now, let's try to solve one problem here using the Maclaurin series. Okay. Okay, I will label my f equals, my function equal to f. So here, now we are going to use eval input. Okay, take note, no. Enter the function in variable t. Okay, enter the function in variable t. Okay. And then put that in y. I will put CLC and sims. Okay, this time I will be using t only as my variable. And then we are going to find what is the tail or the Maclaurin series. Okay, I will change the problem. Find the Maclaurin series. Maclaurin series. Okay, of e raised to x. Let's have this one. Let's have this first problem. So in this case, no, I will display the Maclaurin series. Okay, take note, when you display a string or a string, you have to put a delimiter, which is the apostrophe. The Maclaurin series of, we have Maclaurin series of f, say, is equal to, okay, put the delimiter, and then we are going to solve the Maclaurin series here. In this case, okay, let's have the Maclaurin series, your function of t, okay, that's my Maclaurin series, is equals to Taylor. Okay, Taylor. Okay, Taylor is your syntax in solving the Maclaurin series. So Taylor of f, okay, because now we are going to find what? The Taylor of f. Okay, here we are going to enter a function in variable t. So we will run the code. Run the code. Oh, what happened here? Okay, we are lacking, okay, a parenthesis. Okay, again, run the code and enter the function in variable t. This time I will input e raised to t. So e raised to t is my function. Okay. According to this, no. Okay, sim variable t. I'm sorry, what's the error here? Oh, CLC. Okay, we have a major error here, and okay, I will erase this part and I will create a new one, new script. Okay, I will copy this one, Control A. It hangs. Okay, let's have another one. Here now I will first write a code to clear the screen, and then sims. Okay, we will label that as t, and of course we will have our function here, function of t. Function is equal to, let's say, evaluate, then input, okay, okay, enter a function in t. Okay, that's it. Now enter a function in t. After that, now we are going to evaluate this function using Maclaurin series. So we have here, first we will display the Maclaurin series. The Maclaurin series of a function is, okay, and then we are going to display the function, okay, and we will take the Taylor, okay, Taylor of the variable. So what is the variable? What is our function? F. We are going to take the Taylor of f. Take note. Now this is in variable t. Let's run again the code. Okay, this time now this is exp e raised to t. This is e raised to t. Enter. All right, that's it. No? If your function is equals to e raised to t, the Maclaurin series of the function, no, is equal to 1 plus t squared over 2 factorial plus t cubed over 3 factorial plus t to the 4th over 4 factorial plus t to the 5 over 5 factorial. That's how you encode the Maclaurin series of the function e raised to t. Okay, let's review your Maclaurin series. Okay, like this time, I will enter t raised to n. Okay, t raised to n. Since okay, t raised to n, enter. Okay, evaluate t raised to n. So it's not evaluating the function. It hangs up. This is Control Alt Delete. Pause. Okay, let's have another function here. Let's say t cubed. Let's say t to the 5. T to the 5. Okay, it's simple. It's t to the 5. Again, now we will have another function here. This time I will have my function sine. If my function is equal to sine t, the Maclaurin series of that function is t all over t minus t cubed over 3 factorial plus t to the 5 over 5 factorial minus t to the 7, okay, blah, blah, blah. That's for the function of sine. Okay, let's have another one. Let's say cosine. What about cosine? Let's say cosine of t. What about cosine of t? So this is cosine of t, Maclaurin series. All right, so let's have another one. We have log. Take note, this is ln, log of t minus 1. Let's say t minus t plus 1. Log of t plus 1, run, enter. You have that as log t plus 1t minus t squared over 2 plus t cubed over 3 minus t to the 4th over 4 plus t to the 5 over 5. So that's your log or your ln function. So any questions with ln? Let's try another function. This time we will use the tangent function. Let's say tangent of t. That's the tangent of t. So t plus t cubed over 3. So you can actually solve any function. No? Let's say for any function we have tangent. We have arc sine of t. Let's try arc sine of t. Oh no, arc sine is Control Alt break, and we will change this one. Control Alt break, a sine of t. Press enter. Oh, it's not working for arc sine. Okay, let's try another one, another function. So this time, now we will use a function of, let's say, e raised to 5 times t. So that is e raised to 5 times t. Okay. For some functions, now MATLAB cannot solve it. Okay. Let's try one more time. Run the function, and this time I have here exp raised to t. This was your assignment before. Let's have sine of t times exp. Let's have this function sine t multiplied by e raised to t. So this will be your function. This is the Maclaurin series. So any question with Maclaurin series? Take note, Maclaurin series, your command is Taylor. Okay. Taylor is the command for Maclaurin series. Okay, this time we are going to solve for Taylor series. Taylor series. When we say Taylor series, the center is center is not at the origin, okay, for the Taylor series. Let's try this function. Evaluate the Taylor series. Enter the. Okay, we'll just change this to Taylor series. Now take note the syntax for Taylor series. Now we'll erase this one. You have here the variable and then a. So variable and then a. So this is my f as my function, and the variable that I will be using is t, and the center is at, let's say, 1. Okay. But now we are going to input a here. So you have to input two values, the value of the function and your center. Okay, center. This will be a. A is the center. So input. Okay, input. Okay, enter the center. Enter the center. So you have F and A as your value that will be entered in the keyboard. Let's try. Now, run. So what is the sign of, what is the Taylor series of sign T with center at pi? Enter. Okay. Here, F equals sine t, and A is the center, which is 3.1416, and then the Taylor series of the function is pi minus t plus t minus pi 1 cube over 6 minus t minus pi to the 5 over 5 factorial. Okay. Enter. So I will add r here. Okay. Again, now we will have another one. What is log of t centered at 1? Okay, take note. Log of t centered at 1. Enter. Log of t centered at 1 is, okay, the Taylor series of the function is t minus 1 quantity squared, blah, blah, blah. So that's how you solve for your Maclaurin series and Taylor series. Now, to finalize our topic, now what if now we will combine everything using if else. Okay. Let's erase this one and we will clear this up. Okay, we will clear this up. This time I will create a function. I will create a problem here. Create a program that will prompt the user to select, prompt the user, the user to select the mathematical solution. To the problem. Okay, now okay, you can say, let's erase this one. Choose choose you want, choose a number, choose an operation. Let's say choose an operation below. Let's say 1 here, 1 Laplace transform. Okay, 2. Let's say inverse Laplace inverse. Okay, 3. So take note, these are just comments. Maclaurin series. Okay, 4. We have the Taylor series. Okay, now we will use problems like this one. Okay, we can say choose, so we can display this function. Display display the operation below. Choose or choose an operation below. Let's say choose an operation below. Number one is Laplace transform. Okay, let's say Laplace transform. Laplace transform, that's for our first choice. We have display. Okay, inverse Laplace transform will be our second choice. And display Maclaurin series as our third choice. For the fourth, display Taylor series. All right. Okay, now using the if-else statement, you have to enter a number. Okay, input. Let's label the variable here as f. Okay, f input. Or let's say x on x. Input. Okay. Enter the operation of your choice. Okay. Okay. That's it. Now enter the operation of your choice, and we will adjust this first. And also this one. Okay. All right. Now, using the if statement, you can say if x equals to 1, no, you perform the Laplace transform. So how are we going to perform the Laplace transform? Of course, no, you're going to prompt the user to input the functions. Let's say evaluate. Let's say eval input. Okay. Enter the function in T. All right. Enter the function in T. That's it for the Laplace transform. Enter the function in T, and let's say f of t, I will label this as f of t equals to Laplace of my function t. Okay, Laplace of my function t, and we will display that later on. What about for else if? So else if I selected number 2, what are we going to do? Okay, I will just copy this one and then paste it below. So evaluate, enter the function in T because in S, because we are going to take the inverse Laplace transform. This time I will make this a capital letter. Okay, F. And this will be my F of S. F of S. Okay. Let's just label this as F of T, because we will be displaying later on the function. All right, okay. What about, okay, let's have another one. Let's solve for the Maclaurin series. Else if x equals 3, okay, this time this is f. Enter the function in t. And then we are going to find out what is the Taylor series of your f. Okay, copy this one. Okay, Control C, Control V. So else if, okay, x equals 4. So what are we going to do? If x equals 4, we are going to find the function. So enter the function in T and also input. Okay. Enter the center. All right. Enter the center. So this time, now this is your function of f, and we will have a variable t in the center of a. Else, okay, display. What the heck are you doing? All right, then end the code. Okay, let's try. Let's try this one. Run the code, and you will be prompted, enter the choice of the operation. What happened here is we're going to enter the operation. Okay. Let's adjust this one. Enter the operation of your choice. Display, it should be displayed here. So enter the operation of your choice. This time, now I will enter, let's say 1. I'm going to calculate the Laplace transform. Oh no. 1. If x equals 1, okay, do the Laplace transform. String is not terminated properly. All right. Okay. X equals 1. Okay, I will take another here. Okay, f of x. I will enclose this one to parentheses. Maybe this is the problem. That's a good news for everybody. Let's run again the code. I will input 1, enter. The string is not terminated properly. Where is the string? Where is the string here? Display operation. Okay, okay, display for Laplace transform. Where is the error here? The string is not terminated properly. Okay, I think no. Let's label this as F. Label this as F. We label this as F. Right. The problem is here. The string is not terminated properly. Control Z. Okay, I think there's no problem with our function. Only the problem here is the function is not terminated properly. Sorry for that. Run the code again. Okay, I will pick 1. And you're required to enter the function in t. Take note, we are going to take the Laplace transform. Let's say this is t squared. And the Laplace transform that is t cubed, s2 over s cubed. So we can have display, we can type another display here. The Laplace transform is, and we will terminate this. Okay, let's try now. Okay, I will copy this one so that I can paste it here, and another one here. Okay. And another one here. But this time now I will label this as the Taylor series. The Taylor series is, and of course, the Maclaurin series is a, and the inverse Laplace transform, let's say inverse. Okay, now let's review the code. Okay, I will have here CLC to clear my code. Run the code again. Okay, it will clear my command window. So you will be prompted to enter your the operation of your choice. Now I will select 1, press enter, and enter the function in t. I will enter sine of t. Okay, sine of t. Press enter. Okay, you will have function is sine of t, and the Laplace transform is f of t. Okay, this should be f of s. This should be f of s. Sorry for that, f of s. Okay, okay, let's run again. This time I will select 1, and let's say cosine of t. Okay, it's here, it's displayed. Now f of s is equals to s all over s squared plus 1. That's your Laplace transform. So in this case, you're going to enter, okay, let's try another one. This time we will select 2. 2. Okay, enter the function in S. Let's say 1 over S raised to 6. Enter. Okay, F equals to 1 over S raised to 6. The inverse Laplace transform is F of t blah blah blah. Why is it Z and Z? Okay, because no, so we have a problem in our symbols or your variables. This time ST. We will include that symbol in S and T, and we will select 2 this time, 1 over S raised to 6. I think no, it will not create. Oh no, it's still the same. What happened to my Laplace transform is I Laplace, sorry. For number 2, this is I Laplace. Take note of that because we are solving for the inverse Laplace transform. Let's try again. That's how you debug your code. Let's say S raised to 4. Press enter and charan, it gives you the correct answer. Let's try again. Now this time we will choose to solve for the Maclaurin series. What is the Maclaurin series of, let's say, sine of, let's say, 2 times t. Okay, the Maclaurin series. Okay, the Maclaurin series is blah blah blah. That's it, no? For the Maclaurin series, this time, no, we will pick number 4, and you will be prompted to enter the function in t. This time, no, I will enter, let's say, cosine of t with the center of pi. Charan! The Taylor series is for the cosine function is. Okay. So that's it for today. I hope you've learned something new for today. So guys, now just continue using the live editor because debugging in live editor is really easy. You can easily see what is the error in your code. Okay, let's try another. Let's input, okay, another number here. Let's say I will choose 5. What the heck are you doing? Okay, so since the number is not found in the choices. All right, okay. So I hope you've learned something in our discussion for today. Okay, let's go back to our discussion. Okay, next meeting, I will be presenting another programming using loopings. Loopings now is used in Fourier series. We will use looping in Fourier series. And for the last laboratory that I will teach you how to use graphical application, how to create applications in Maclaurin. So, any questions for today? I hope you've learned something new for today. And don't forget to subscribe in my channel. Okay, and hit the notification bell. Okay, that's it for today, and I will see you next